welcome to Study Guide Forum. Today we'll be looking at another exciting topic. This topic has to do with stoichiometry. Stoichiometry happens to, in some cases, we say it's a mass-volume relationship. It helps us to understand the mass and volume relationship in every chemical reaction, as well as the volume. It will also help us to understand how the volume, if it's gases, if the reactants, they are gases, it will help us to understand the way they react. Today, we'll be looking at some chemical equation that has to do that will help us really understand how this thing, how the reaction goes. Now, in this one, the question said, find the reaction stoichiometry and use it to predict the mass of chemicals used in the reaction below. So what we are going to do here is to find out, so that we should find the what? The stoichiometry, that is the relationship that exists here. The stoichiometric ratio is one of the things we are supposed to find out. In this case, if we are to get the equation solved. In the chemical equation, have the sodium hydrochloric acid reacting with sodium hydroxide to give us sodium chloride and water. Now we have the molar relative molecular mass of chlorine, and then relative atomic mass of molecular mass of sodium chloride too. So in this case, the question said, how many moles of hydrochloric acid are required to react with 4.75 moles of sodium hydroxide? The second one said, what will be the mass of 4.5 moles of sodium hydroxide? And then the last one said, in a repeat experiment, 54.75 grams of HCl reacted completely with some sodium hydroxide added. What was the mass of sodium hydroxide used in this experiment? So all these questions given to us, all of them boils down towards the stoichiometric relationship, the mass-volume relationship. All of them boils down there. Our ability to really use a balanced chemical equation to determine what a chemical reaction will look like. That is just, to me, what I feel about it. Anytime I see a chemical equation, one thing that comes to my mind is, this is what happened in this. This, and that is what you're going to see. So that is what we're going to look at now. Let's quickly look at the first one. It said that how many moles of HCl are required to react with 4.7 moles of sodium hydroxide. Based on that, so from our chemical equation, balanced chemical equation, the stoichiometric ratio that exists here is that 1 mole is to what? 1 mole of this reaction, because we are talking about what? Sodium hydroxide. That is sodium hydroxide and what? HCl. Now, since it's 1 mole, what it simply means here is that for this reaction, since we are looking, say that we react with HCl, that we react with it means that sodium hydroxide, 1 mole of sodium hydroxide will be equal to what? 1 mole of HCl. 1 mole of HCl. So in that case, now we talk about the mole. This mole of, what do we have here? 4.75 moles of sodium hydroxide will be equal to 1/1 times 4.75 moles. That will give us 4.75 moles of HCl. Because 1 mole is a 1 mole, that means 4.75 mole will also be for what? So 4.75 mole of what? HCl. this one is done. Remember, the question said that we determine the mass. If we are to determine the mass of this reaction, to determine the mass now, simple, what we are going to do here is, now, since we know the moles, and we know that mass, a mole is mass over molar mass. So we have the moles, the mole of sodium hydroxide. That means to get the mass will be mass is equal to moles times ml, molar mass. Let me make it in full this time. So what we have here for sodium hydroxide, we have let's say mass of sodium hydroxide. We have 4.75 times 40. That will give us 4.75 times 40 will give us 190 grams. That is 190 grams of 190 grams of sodium hydroxide. So we look at the other one, that of the HCl. We know that for HCl we have a mass of HCl will then be 4.75 times 36.5. That will give us approximately 173 grams. So that is what we have in this case. Now the second question says that, what will be the mass of 4.5 moles of sodium hydroxide? That's the next phase of the question. What will be the mass of that? Now from what we have done so far, we know that the relationship circles around here. So what we're going to do again is to just run through it. If we run through it, we have mass of sodium hydroxide. That will give us 4.5 times 40. We have 180 grams. That is 180 grams now. So the next thing we're going to do here, the last question that we have here is the one that said, in a repeat experiment, 54.75 grams of HCl reacted completely with some sodium hydroxide added. What was the mass of sodium hydroxide used? So in this case again, we'll go back to the relationship that we have there. We'll go back to the chemical equation. From the chemical equation, we know that sodium hydrochloric acid plus sodium hydroxide will give us, so here we have a 36.5 grams will react with what? 40 grams of what? Sodium hydroxide. I believe that all of us were following this. So this is the simple way of using chemical equation to get work done, to get the calculations, everything that you want. So because we know that from this ratio, this means the mass of this, everything we have here will give us what? The mass involved from this balanced chemical equation. Now someone might ask me, where do I get this? It's already given to us here. But perhaps for any reason, if you really want to know more about it, I can give you the opportunities. Hydrogen here is 1, chlorine is what? 36.5. Adding up together, we have 35.5. We have this. That's how we got that. The other one we have it's already there too. 23 plus 16 and 1. We have it to be 40. So now the mass of hydrochloric HCl here from the equation is we'll find out what we're going to give us now. What are we going to get from that? It will give us 40 over times over 1. So when we do this, what we have here should be, when we divide through, we have 60 grams of sodium hydroxide. So now to make the whole story short, some of this calculation that has to do with stoichiometric is a question of looking into the balanced chemical equation and pick out what you are asked to do. For example, you know that I'm working with what I have here. This is equal to the same mass. This is mass, the molar mass, or the mass that is reacting. That is what I use here, and it's going to give us the same thing here. And the mass of this. This means when this mass reacts with this mass, it will give us a mass of this and the other mass of that. Now, if we don't want to talk about it in this case, we look at it in the terms of moles. If you are given in terms of moles, now we want to find out the moles. Then we can also erase this. Let's look at it the other way around. We say that mole, let's say this is 1 mole, 1 mole, 1 mole, 1 mole. So in this case now, for any reason, if this one is something like 2 moles, it means that all of them will just be 2 moles. So, but now, one will ask me, does it mean that if this one is 30, all of them will be 30? No, this is where we play, where the game changes. Because this one is 36, 36.5, this is 40, this is 40, and this other one will be about 58.5. Think about 58.5, that is what it should be. Let me check. We have yes, we have it. Is that so? The same thing here. We have 18. Now, the masses varies based on the reacting masses is different based on the relative atomic mass or the molar mass of each of them. So for this now, the reacting mass here is 36.5 times 2. For this one, the reacting mass here is what? 2 times 40. And this other one, 2 times 58.5. And finally, we have 2 times 18. All these things gives you the what? The masses that will give us exactly the same thing we have here. So this is just how everything goes. Remember I said it has to do with mass volume relationship. Now if we're talking about volume too, in other way, perhaps if you go to my playlist, you will see some other similar question that has to do with moles, that has to do with what? Volumes, volume to volume. We see mole to mole, we see mass to gram, mass to mole, or mole to grams, as the case may be. When you go through that this thing, you will be able to see some other areas that and some other similar calculation that will help you appreciate this so much. Thank you so much for this wonderful time.